You'll notice that both equations I've given here are already set to 0, which means that everything has been moved to the left-hand side and the right-hand side is equal to 0. If this isn't the case, that would be your first step. That is, the first thing we do with a question that doesn't have a right-hand side equal to 0 is move everything over to the left. Once everything is over to the left, we'll factor it. For x squared minus 4x minus 21, we've got a trinomial. Try that one out. What is x squared minus 4x minus 21 in factored form? Well, I'm just looking for two numbers that when I multiply them give me negative 21, but when I add them give me negative 4, because this is the best case scenario trinomial, where I've got a 1 as the coefficient for the x squared term. And the answer is x minus 7 times x plus 3. So I factor the left-hand side, and that's still equal to 0. Because I have two factors on the left, if either one of those factors is equal to 0, the entire left-hand side is equal to 0. In other words, if x minus 7 were to be equal to 0, if this first part, this first bracket, this first factor is equal to 0, 0 times whatever this guy is still 0. What value does x have to take on in order for x minus 7 to be equal to 0? To find that, we just solve the mini equation x minus 7 equals 0, and we find that x is equal to 7. Try that. If you substitute in 7 for x, you get 7 minus 7, that's equal to 0. And for the second bracket, I don't really care what we get, but we do get 7 plus 3 is 10. The reason I don't care is because we're about to take that 10 and multiply it by 0. Anything multiplied by 0 is 0. So x equal to 7 is one solution for our equation. All right, what if the second factor is set to 0? If x plus 3 actually gives us 0, in other words, if x is equal to negative 3, that once again means the entire left-hand side is equal to 0. So there are two solutions to this quadratic equation, and they are x is equal to 7 and negative 3. We can write this as 1, saying x is equal to 7, comma, negative 3. As soon as we have a term that has an x squared, we will always have two answers. So we'll see that over here as well. If the highest power that x is squared to is a 2, we again expect to have two answers for x. Let's try factoring 2x squared plus 6x. Well, here common factoring is our answer. 2x squared plus 6x has a common factor of 2x. Once I take that out, I have x plus 3 left over. So that's the factored version of the left-hand side, and that's just equal to 0. I can think of this monomial as one factor, and this monomial as the other. 2x is equal to 0, x must be equal to 0. Try it. If I substitute in a 0 for x, what happens to the entire left-hand side? It's equal to 0. So that tells me that x equals 0 is a solution to this equation. Or maybe x plus 3 is the one we set to 0. That gives me x has a value of negative 3. If you take x equals 0 or x equals negative 3 and substitute it into the original equation, you'll of course get a true value as well. So we can summarize this as x is equal to 0 or negative 3. In math, when we say or, we mean and or. It could be equal to 0, it could be equal to negative 3, or it could be equal to both. Mathematically, in this case, it can be equal to both, but it might be one or the other depending on the application that led to this equation in the first place. The kind of question we'll encounter on the test is actually a little bit simpler than what we just did. The ones on the test are pre-factored. So this is the part that you're looking for. You're dealing with a pre-factored equation, which means we would have started with x minus 7 times x plus 3 equals 0, or with 2x times x plus 3 equals 0 for the original two that we just did. In the case down here, our question says, what are values for x if 9x plus 7 times 9x minus 2 is equal to 0? This is an easy question. It's already been factored for us. If we expand it, we'll just have to factor it again. So we use this question as is. We have two factors on the left, and we set each to 0. If 9x plus 7 were equal to 0, what would the value of x be? In other words, what is the value of x that makes our equation true? Or if 9x minus 2 is equal to 0. So we solve for x in both of these mini equations. So first we have 9x is equal to negative 7. Dividing both sides by 9 gives me x is equal to negative 7 over 9. For 9x minus 2, I get 9x is equal to positive 2, and dividing both sides by 9 here gives me x is equal to 2 over 9. So how would we enter this on MyLab? We'd say x is equal to negative 7 over 9, comma, 2 over 9. Those are the two values that you'd put in the box. You don't believe it? Substitute them back into the original equation and make sure that negative 7 over 9 and 2 over 9 both give a left-hand side equal to 0. In other words, both make it so that the left-hand side equals the right-hand side, making the equation true.